I used to think of soil as something that you stuck a plant in so it could hold up. And then we put whatever it needed to grow it on that. And so once I understood it's the biology in the soil that feeds the plant, and so it's essentially, that is its stomach. It gets its nourishment through the biology. What I think is really cool is that plants aren't vegetarians. They eat microbes, so I always thought that was cool.
Not far from where Brad Turner grew up in Lithia, Florida, stands an old forest. He enjoys visiting the wooded area, not only for the solitude it provides, but for the mysteries it holds. For somewhere locked in the roots and soil of this stand may lie the key to revitalizing Florida's citrus industry. Brad Turner grew up in citrus. His family grew oranges and grapefruit in Central Florida since 1921. A fourth-generation grower with over 40 years of experience, he felt the highs and lows that comes with working in the groves. But years of fighting disease and high operating costs would finally take its toll. And in 2015, like so many in the industry, Brad was completely out of citrus.
I didn't own or manage a single citrus tree anymore. I had to go to the grocery store and buy an orange, which killed me the first time I did that.
For a while, Brad found work managing a friend's cattle ranch, but his heart was still in citrus. It was during this period that Brad stumbled across a process that would not only get him back into the citrus business, it would change the way he viewed agriculture. While watching a TED Talk on soil health and plant nutrition, Brad was introduced to regenerative farming. Regenerative farming focuses on soil health through biodiversity, rather than relying on the traditional top-down approach of applying synthetic fertilizer, pesticides, and fungicides to grow crops. This form of agriculture focuses on the vitality of the topsoil, encouraging healthy microbial populations and insects in the soil to improve plant growth.
There is such a huge difference in how traditional agriculture versus regenerative agriculture affects soil microbiodiversity. We want a supportive culture that restores our ecosystems and that values ecosystem services. And so we have to really reframe the way that we think about agriculture. We're not growing trees and plants, we're growing soil.
Brad recognized regenerative farming as an opportunity to help the citrus industry. He began researching, attending conferences, and visiting farms around the country. In June of 2017, Brad was about to undertake a 2-year trial in a friend's grove when he heard about a discovery in another Florida grove. Fellow citrus grower Ed James suffered from massive production losses and began selling off his dying groves.
And I was going to keep one grove, try to grow an alternative other crops, and I knew that I needed to help, fix the soil. In the process of putting out cover crops, I saw changes in the trees that remained that I didn't push out and clear. The more I looked into it and studied it and practiced regenerative, it completely turned the trees around. Good production, high Brix, good quality fruit.
While visiting Ed's grove, Brad found few signs of pests or disease, just healthy, productive trees. Ed's work in the grove demonstrated to Brad a tenet of regenerative farming. Fix the soil, and the soil will fix the trees. More importantly, Ed's results meant Brad did not need to hold lengthy trials of his own. He could move right into the research.
That was a big day for me. June 9th, 2017, that was really cool. That was probably the biggest day of my life, next to marrying my wife, probably was walking into that grove that day. That was cool.
Brad purchased a 5-acre tract to begin his own research under his new business, Sand to Soil Services. He wanted to learn which traditional farming practices could be cut and which new beneficial practices could be adopted to help make Florida citrus flourish once again. Brad began working with other farmers and growers who were seeking ways to fix their groves. For citrus grower Doug Doudney, the road to recovery began with Project Tree Number 1.
The most dramatic change was a tree that became called Project Tree Number 1. Took some pictures of it, put a flag on it, and called Brad and said, we've got our project tree here. And Project Tree Number 1 in June of 20, we started kind of putting the kitchen sink on it. And by July of 20, just a month later, I've got a picture of the old leaves that remained were the size of a silver dollar, but the new flush was about twice that size. And there wasn't a lot of it, but that was a sign. And at bloom time this year, that tree had refoliated. It set a crop, and it's carrying a crop now for the 21-22 crop.
As part of his research, Brad continually studies the old forest. Here, hardwoods, softwoods, grasses, and other undergrowth thrive in their own ecosystem, interconnected through a massive root-connecting fungal network. But what most interests Brad in this forest is the presence of several healthy, unattended citrus trees. Unlike in traditional groves exposed to full sunlight, these orange trees are thriving in the shade of oaks, sweet gums, and maples. Through frequent sap tests and soil analysis on the trees, Brad is trying to better understand what Mother Nature is doing here and how to replicate it. How, for instance, are the wild orange trees able to absorb minerals like calcium in levels unseen in the groves?
I've never seen calcium levels in any leaf test anywhere that high as I see in the woods. It's impossible to do in citrus. Even here, I'm not getting calcium levels high enough. So that tree is asking for the mineral that it needs because it's getting some sunlight, but it needs every advantage it can get to get sunlight to feed itself, to drive the system. So I just found this out a few months ago. That's very cool. In my world, that is very cool.
The wild citrus trees, or more specifically, the soil around them, is the source of one of Brad's most important tools, an organic inoculum used to promote soil health and add biology to the foliage. From beneath the trees, Brad gathers a few inches of topsoil. He then mixes the rich matter with earthworm compost and adds fish hydrosylate to feed the biology for a month or two to promote good fungal and bacterial growth. When it is ready, Brad will place 5 gallons of this inoculum in a fine mesh bag, set it in a 250-gallon container mixture of water, fish hydrosylate, and molasses, and let the microbial multiplying process begin. Steeping like a tea bag, the compost seeps microbes into the solution, keeping them viable. Most of these microbes then begin to split, replicating geometrically. Some about every 20 minutes. In a 20-hour period, a single beneficial microbe will have split into millions. By growing his own microbial inoculum, Brad can feed his trees at a minimal cost. The costs associated with growing citrus are forcing many growers to walk away from the business. They can easily spend upwards of $2,500 per acre per year on inputs alone. With regenerative farming, it's possible to spend $1,000 or less. And once the process is up and running, the associated costs will go down as Mother Nature takes over. Through frequently testing of the Brix, or sugar levels, of his trees, Brad is seeing that healthy trees can naturally ward off pests and diseases. He found that trees with a lower Brix level, around 1 to 5, are highly susceptible to a variety of pests, from psyllids to grasshoppers. But as the Brix levels increase in a tree, the number of invasive pests decreases. A tree with a Brix level of 13, Brad found only the grasshoppers remain.
And then when you get to a 15, which it can be I've seen it done, so I know it can happen. There's not many insects that will touch that plant. So you don't have a psyllid biting you anymore. And even if you have greening, if you got a 15 Brix plant, that tree doesn't know it has greening. That tree is just growing.
Just by fixing the soil, the trees have fixed themselves, and the crops have taken care of themselves.
Fixing the soil does more than promote healthier tree growth. Farmers also see a reduction in runoff. Through cover crops and non-till practices, the soil's stable organic matter increases. Rather than becoming compacted, the soil remains loose and aggregated. A 1% increase in organic matter in the topsoil has the capability of holding approximately 18,000 gallons of water per acre. In May of 2018, soon after Brad bought the property, 21 inches of rainfall left enough standing water to kill half of his trees. 3 years later, 3 inches of rain in 1 hour will completely soak into the soil. Like the wild citrus trees in the old forest, Brad Turner is finding a way to thrive in a new environment. From a fourth-generation citrus grower once forced to buy oranges at the grocery store, to a self-educated researcher dedicated to helping Florida citrus, Brad is at the forefront of farming innovation. Through a blend of old and new practices, he is demonstrating that good soil health is the key to sustainable, affordable agriculture.
This is the process. This is the way plants and food are supposed to be grown. It's the natural growing system. It is, and it works, and it's inexpensive. My goal is to, help citrus growers keep going, and this is what will do it. And I'm confident in 10 years this will be the norm. You'll see plants growing wild, all in citrus, all up and down the state. It'll be that way. It's going to happen. This is really all I think about. This is what I'm doing now. It's fun. It's just what I am now. It's just part of me.